Welcome everyone. We're going to go ahead and get started this morning. Thanks for coming in. We'll have some more people joining in as we go along. And this is our first online class. The date is Tuesday, of course. We are at March 17th. Happy St. Patrick's Day. And I'm going to go ahead and share my screen and get started. If you want to follow along in Canvas, you can go to our Canvas course site, and I'll be stepping along. I tried to get real organized this morning so we can follow along very easily. So I'm going to share my screen, and let's see which screen I need to share. I've got a bunch of them here. Let's see. I'll go ahead and share. Let's see, I'm already sharing that one. I'm already fumbling just a little bit to see where my Canvas screen is. I'll do show all windows. And this is probably the one I want to share. Let's see. Yep, here we go. All right, can everyone see my screen with week 11? And Harshini, I might keep you online if you could let me know if everyone can see that.
Yeah, we can able to see that.
Okay. So basically what we're going to do is we're going to start with the outline for week 11. This is what we're going to do. And I'll try to follow this format. I'm going to try to stay super organized. So if you miss the online lecture, you can view the recording of it. I'll have a recording posted, or you can, just follow along basically without an outline. And so basically what we're going to do is go over the course schedule very quickly again. I've made a few changes to that. There may be some adjustments as we transition to this online schedule. I don't know how long it will be. Some think we're going to be doing this until the end of the semester. So I'm prepared for that. And then what we're going to do for second is I want to talk to you about the Google Cloud Engineer Coursera course. And I'll talk to you about that so you can make a decision as to whether you want to try to join in on that course. I think we'll see some repetition in what we've done already. It is more of an engineering class and more of a networking class, how to handle the cost and the provision of resources, which is very valuable to you. You have to analyze whether it's more valuable to you to go ahead and go through that class or to go ahead and keep working with our material that we have now. So this course, as I'm going to mention this several times, completing the class will give you a certificate. Sitting for the exam and passing the exam gives you a certification. The certificate and the certification are two different things, and we'll talk about what's required if you want to use this as a substitute for the exam. And then we're going to go over Chapter 6 summary. I've got a GitHub site set up that I'm going to be using to post samples for the machine learning models that we're going to be using. And then we'll have an introduction to Chapter 7. Many of these introductions are focusing on the case studies and how this case study relates to this machine learning process, because that's what's important for your application to our project. Everyone still has to do the project. The Coursera class only substitutes for the exam. So you're still going to be getting the material through the project. And then I've got some homework. We'll talk about that PySpark assignment and data camp. I've extended that date just a little bit due to our transition, and then our project. All right, so first off, let's get started. The first, I did want to mention also, I've got information on a link to the 9er notices regarding COVID-19. That gives all the information that we have on classes. Apparently they're assessing every Monday whether we stay on this online format or we move to back to a face-to-face format. And again, my guess is that this is just watching how things are going. This is going to be going on for a while. All right, so here is the Associate Cloud Engineer track. There is a video here. I don't think we need to watch this together as a group. It's short though, it's 5 minutes. And I recommend that afterwards, as you're making your decision as to whether you want to do this, you can watch this short video from Google. This will give you some information on what this Associate Cloud Engineer track is. Google has given me my own class on Coursera. I can invite up to 50 participants. I'd like to keep that to this class. If you've got someone that is enrolled at UNC Charlotte, that's a graduate student that would like to join in, perhaps a former student of mine, please let me know. They can make a request and I might be able to add a few more in. Obviously, we will have some people in our class that don't want to join in, so I'll probably have some spots. I just don't want to take away the time and attention from classmates that are going to be trying to participate with this. This is separate from class. We'll be setting up some separate sessions called study jams. Google's given me some training with this to keep people moving and motivated. So watch this to learn more about it. And then also, let's go over to the next part. We'll close that tab. I've got a little bit of a PowerPoint here that I'm going to run through quickly that talks about getting started with the Associate Cloud Engineer track. This has some more information about it. Basically, we know that cloud is very important to everything today. And depending on whether you're aspiring to be a data scientist, data analyst, a cloud infrastructure engineer, or a cloud native app developer, there are a lot of tools. We've got Amazon Web Services, Microsoft Azure, Google Cloud Services. There are lots of different tools out there. And if you learn any one of those, and particularly if you get certification, it can be very, very valuable to your career. The idea is even like if you get Google certification, that certainly will show that you're able to work with the cloud, even if you're applying for positions that require Amazon Web Services. And that once you get one certification, it's kind of easy to get others. The Google certification, from everything I'm seeing, is probably a little more difficult to get than Amazon Web Services, and that in a way makes it more valuable. If you get that, you should easily be able to study up and get the Amazon. All the concepts are the same, just like in programming. So this certification, they start with this. I don't have a choice really, but this is the Associate Cloud Engineer certification that they've set up a class for me with. The program benefits, it is on demand. There's self-paced labs. You get Google Cloud certified. Now, finishing the class gives you a certificate of course completion. That finishing the class, that certificate counts for your pass from my final exam. 30% of the class. You have to finish the entire course, so you can't finish half of it and get half credit. It's got to be all or nothing. So if you get to the last day and you have not finished this class, maybe even only have a few more modules, then you'll have to take the final exam. So I want everyone to be crystal clear on that. This is not required. This is totally optional. And you've got 16 weeks to finish it, so you don't, if you get into it and think, oh, this is too much work, that you can still do the final exam. So again, this is totally optional. And so here's some prerequisites. I think we all have this. Operating systems, file systems, the IP networking staff. I can put a review of that. I feel like everybody has had some basic instruction with the IP networking staff, how web browsers and web servers communicate, databases, programming, working with Linux at the command line. We're getting that in our course. Editing text files from the Linux command line. So I think we're pretty good to get started on this. In fact, it uses Quick Labs. I'm guessing that some of the Quick Labs might be some of the ones we've already done, which is great. Let's see what you will learn. You will learn how to explore and deploy solution elements, including infrastructure components, network systems, etc. So lots of good stuff, things that we've already learned, but it is going to focus more on that engineering side of things. And you will earn a course completion certificate upon completing the courses successfully. You can also get the Associate Cloud Engineer certification by passing the exam. I think the exam is $125. You get a half price certificate on that. I'm going through the class. I'm going to take the certification exam. My goal is to do that certainly ahead of you and before the end of our class, so I can help provide guidance on that. And so this is the timeline, but everything I'm seeing, they give you as much as 16 weeks. I've seen evidence online where people have completed this in 4 weeks. And what a perfect time to do this, right? Because of our online classes, and you've probably got plenty of time on your hands. So I think this will be a good time to do this. And I've got all of this stuff bookmarked. I'll be pushing out more information on this. So let's go ahead and skip over from our outline. I'm going to go ahead and close this. Now, I've got a link. If you'll go back to our course module, there's a link to a Google form, request to enroll in Google Associate Cloud Engineer. You will, when you go to this form, and if you're not interested, you do not have to fill this out, although it'd be kind of nice for me to get everyone to fill it out so I know that you know about this and you've had a chance, because I will cut off the enrollment, I said by end of day Thursday. I'll probably send out a reminder email for this, but I'd like to know if you're interested or if you're thinking about it and want some more information. But again, I've got the information on this. It's optional. You do not have to do this. If you complete the course and get the course certificate, that is your ticket out of my final exam. Not anything else. So you still have to do any other assignments I have, even if there's some overlap with some of this, you still have to complete the project. But I will let that count for the final. That's 30% of the class. If you don't get through, you have to take the final. So, and again, this is optional. You do not have to do this. The final exam will be online. I feel like this is maybe a little more difficult than the final exam, but there's always some, this may be very valuable to you though, depending on what your career trajectory is. So please fill out this form and send this to me. I'll be monitoring this and seeing who wants to enroll, and then I'll send you an invite to enroll. We'll have a separate study jam session once every week where we get together, and I'm supposed to be your cheerleader and keep you going through this class. Might be easier than we think because it does use quick labs along with instructional content and exercises, and I believe that we've probably already done some of this. So anyway, that's that. And let me go ahead and close this tab. And then here's some more information on the Associate Cloud Engineer that you can go through. These are the things that an Associate Cloud Engineer exam assesses your ability to do. This is for the exam: set up a cloud solution environment, plan and configure a cloud solution, deploy and implement a cloud solution, ensure successful operation of a cloud solution, and configure access and security. These are all those back-end things that are so important that really are an extra asset to you, I think, when you're applying for positions. Any kind of certification is good, and this one certainly is a technical certification that would be very good to have. Totally optional. All right, so I'm going to go back to our course module. I'm going to pause for just a minute. We have, for our instruction so far, we have gone through our Google Associate Cloud Engineer track. We've gone through all of this material. I've introduced the form the request to enroll in the Google Associate Cloud Engineer. I'm going to pause for just a minute and see if there are any questions. And I want to keep sharing my screen. I don't know if I can see the messages on here. Like I said, stop share, annotate more. We've got 15 people in. Harshini, do we have any questions?
No, no, Professor.
Okay. So everyone, if you'd like, you can go ahead, and if you want to do that Associate Cloud Engineer. One final thing, if you get started on that and decide you don't want to finish it, that's okay too. No penalty for that. That's, again, it's entirely optional. You can work at your own pace. You have 16 weeks, which goes beyond our class, to finish it. I will keep working with students beyond our class to help them finish. But if you want to go ahead, we've got, almost 7 weeks and to finish this. And I think with all the time you're probably going to have on your hand, it might be very doable. Okay, if there are no questions, I'm going to move on. So next, what we're going to do is just revisit Chapter 6 and look at some resources for Chapter 6. I've got 2 things on our outline. I'm going to talk about a Chapter 6 summary. I've got a little PowerPoint to help me guide what I'm going to say there. And then there's a GitHub repo for machine learning review. If you want to take a look at that, there's a video here also that's really good on naive Bayes classifier. So in our class knowledge-based systems, we're learning this whole system of how to, put up a fully ingested machine learning model. We'll do a little bit of rules-based system for a week towards the end of the class. But we're also reviewing these classifiers, these machine learning algorithms. And so I've got lots of great material for you there. In this video, if you're like, I'm not real sure about the statistics behind even naive Bayes or logistic regression, I've got great resources and examples for you to review. And then we'll review some of that in class also. So let me go to the Chapter 6 summary. And here we go. I'm going to go through this. What we're going to do, so basically Chapter 6, which we've covered basically through our quick labs and through our work in class, we found that that was very heavy. It had a heavy load on our cloud resources. And so we've gone through the quick labs. We haven't really tried to do a whole lot with it in terms of actually implementing it inside GCP. And there may be some techniques from Chapter 6 that you'll be using in your project. So basically, we added a variable to our project. What have we learned after adding the second variable? The variable that we added was distance. And we've learned that as distance increases, departure delay threshold increases. And so we ended up with several bins. And so basically what this means is that if we look at one of these bins, for example, we'll look at the 1218 bin. This is flights. This bin is flights from 838 up to 1218. And what this means, that 18 means we need to cancel the meeting only if the flight departs 18 or more minutes late, because the 15-minute delay can be made up en route. And so what we're seeing is that the longer the distance for the flight, and this was from our modeling that we did, the longer the distance of the flight, that decision threshold gets larger. And the chapter takes you through how we actually ascertain this based on our decision threshold for our model. And so this is 0 up to 368 if it's 15 minutes. If the flight departs 15 minutes or more late, we need to cancel the meeting. This is 368 up to 575. That's at 17 minutes late. So that's what we have learned by adding that second variable into our model. And so the second variable is pretty valuable to us. And we saw that we are making, we've got better accuracy with our decision also. And so we looked at, and this is how we ascertained that. If we look at 368 and 15 first, if we look back to our Chapter 5 evaluation criteria at one variable, we were at 30.2% accuracy. And if we look at the two variable model, we're at 34% accuracy. So we're making a more finer grained decision. Adding in departure delay from this chapter showed that we have a better model. And so that was good. And so the tooling for Chapter 6, we learned a lot more about Google Cloud also. We used a 3-node Cloud Dataproc cluster in Chapter 6, and Cloud Dataproc made it easier for us to work with Hadoop. Before, in Chapter 5, we were using BigQuery, and we did not have to use Hadoop. We did not have to manage our own clusters. BigQuery does that for us, so that BigQuery is a lot easier. If you're thinking about implementing things in your project, you can stay right in BigQuery. I'd like for you to try some of these other things, because this gives us experience with Hadoop and also Spark. We're able to create, resize, and delete clusters because we aren't deleting the data. The data resides in Google Cloud Storage. And so we can spin up a cluster, whether we're using any of these tools. We can spin up a cluster. We can, after spinning up a cluster, we can do our processing, and then we can delete the cluster. The data is on cloud storage. It persists, it stays there. Anything we save will stay there. So this is very, very powerful for us, and it brings all the tools that Google has to us for our projects. Development occurred on Cloud Data Lab. No, that's not a new tool, it's Data Lab with Jupyter Notebook and Python, and then we had a pig interpreter also with Spark. Okay, so we've got, with Chapter 6, BigQuery, Spark, SQL, Apache Pig. They're all integrated into the workflow on the Hadoop cluster. So what are we doing as we go ahead? We're getting ready to go ahead to Chapter 7. Chapter 7 introduces more variables. So we're going to be introduced to feature engineering. And I've got some more information on feature engineering. How do we select the right features? Chapter 7 will go into some considerations for that, which we'll cover in just a minute. And this, all of this does model what we learned in knowledge discovery and databases and what you're learning in some other classes as well, the big data class and so on. Some of it I know is repetitive. That's a good thing because, you're able to see how these tools apply in different settings, and it's pretty complicated. So it's good to learn about this process as well and be exposed several times. So we're going to be doing logistic regression. We did Bayes in chapter 6. We're going to be moving into logistic regression on Spark. You also, for chapter 7, have an assignment that parallels this in Data Camp with PySpark. I've got a video for you on logistic regression where you can learn more about that. And then also keep in mind with your project, you should be setting up your GitHub site, and we've got a deliverable coming up for that particular, for your project with your GitHub site. All right, so chapter 7, we're going to start with data science on the Google Cloud Platform on GitHub. And let me go ahead and get back to my course modules. Let me see if there are any questions. Harshini, can we see if there's any questions on chapter 6 and summarizing what we've learned there?
No, there are no questions. You can unmute and ask questions if you have any doubts.
Okay, that's all right. I was and monitoring, let's see. And yeah, let's see, remote control more, stop video. Is there a way in the messaging, let's see, here we go, mute. And microphone array, I think that's for me. I'm not sure how, let's see if I can unmute here. I'm getting used to this play. Oh, I can see unmute all. I don't know how the feedback, I guess I can try that. I'm going to try that, everybody. And we've got 16 participants, including me and Harshini. So not too many people joined in, but hopefully people will watch the recording. I did make it clear that you could watch the recording. And we've been told at the university, we have to be real careful about the synchronous classes because some people may be traveling. I think as we go along, we'll have more people join in, hopefully. So I'm going to click on unmute all. Everyone's unmuted. You're laughing. Hello, everybody. I hope people are paying attention.
Hello.
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 How is everyone?
Good. We are good.
Good.
How are
Am I
you?
talking too fast?
How are you?
I'm fine. Am I talking too fast for everybody?
No, we are good.
Okay. So any questions so far?
No,
Not yet.
good.
Are there more than 16, or did some of you meet and you're watching with other people in the room? No, it sounds, I don't know if you're getting together with your groups. Okay. Any questions on the Google Cloud Engineer course? Let me go back to that.
So if we get the course completed in Coursera, then that would count for the final.
Yes, if you have and trust me, that is no easy feat. But if you have the certificate of course completion, that counts for final. Let me make it perfectly clear. If you were missing 5 minutes of instruction when the final is ready, and you don't have that certificate, then it does not count. So you have to complete the whole course. It's all or nothing. You complete it and you get credit for the exam, or you don't complete it and have to take the exam. But that can even be the last day. That could be 5 minutes.
Okay.
Okay?
Yes, got it, Professor.
And I think there's going to be some overlap. I think some of the quick labs are things that we have already covered. I've got to get into it.
I'm not.
They are not
I've been with internet.
They are not
Any other questions?
Thank you. Do you have any I am, but they're gonna keep us on. So. Campus? Alejandro sent me a text. She was asking me like the questions.
Okay, I'm gonna go to no questions, and you can use messages. I'm gonna mute everybody.
Yeah. I don't Google campus anymore. So, like probably like a year ago, I would have to set up. Like my internet last.
Okay, I'm gonna go ahead and mute everybody.
Because I got a
You can unmute yourself if you have a question. All right. Are we ready to continue? We're gonna continue on. With any luck, my cats will make an appearance, my 17-year-old cats, but they have so far been staying away. All right, let's keep going. So we have covered, hopefully this is working well. I'm trying to be super organized for you. We've gone ahead. I did not go over the online class schedule. You can take a look at that. I did have the information on the 9er notices, but I do have that online class schedule here. I'll be updating that as we go along. That'll be a part of every module. We've gone over the Google Associate Cloud Engineer track. We've gone over Chapter 6 summary. Now let me introduce the GitHub repo that I have where I'm setting this up to go along with the chapter. This is mainly a repo to help provide materials that are available to you for some of the modeling that we're going to be doing. And so if we go to, there's my outline for the week. Close that tab. Here's that repo. If you have suggestions for things to add to this, let me know. I've got this set up with the table of contents. Hopefully everybody knows how to do that. If you need, because this would be a great way to set up your projects. It's pretty easy. It's just using HTML, and, you know, basically, I can go into edit mode and you can see that. You can see that this is just using the tags, document tags. It's using HTML and then using the name tag to go down to that area. Okay, let me go back into this so you can see how that's done. So I'm going to be building this as we go along. I've got Chapter 6 out there. I'm still working on Chapter 7. What Chapter 6 does, basically, it gives you a little introduction. And then what I've got materials for an introduction to the Bayes theorem for machine learning. And so this is pretty important for you. I highly recommend, we've got the whole class, basically. A lot of you are at different stages of this. Anyone that had the KDD class has gone through much of this already, but it certainly doesn't hurt to have a review. And Analytics by Vidya has an excellent introduction to Bayes. Here's a great video that you can watch. You might want to get together with your group and watch this video on naive Bayes. It also goes over the Bayes theorem in general, and then how naive Bayes works, which is basically just a probability theorem. And then this is what's really cool. This Python example in Google Colab. I set this up. This has an example in code. I'm going to go ahead and right mouse click on this and open this in a new tab. This gives you a naive Bayes notebook just to see simple code. Where is my tab? Got to find my tab and see where that opened. Here we go. It's going to take just a little bit to spin up. If it doesn't go pretty soon, I'll go ahead and kill this. But what this is going to do is spin up with a notebook, and then you could also, yeah, it says, sorry, something went wrong. I don't know if it's got, don't know why that would be. Let's see if I can refresh it and it'll go in. But this does work. There we go. So this is really cool, and I can show you how to do this also for your projects if you want to have something like this for your projects, or, you know, I know we're doing Google GCP. We're wanting our projects to be a Google Cloud platform, which reminds me, I've got to show you how to set up your project site. I'll have that by Thursday for UNC Charlotte. But what you can do, if you click here and open in Colab, what this is going to do is this actually opens this code right from GitHub with that Colab button. It opens it in Colab, and you can actually play around with the code. So what a great resource this is. This is a lot of fun. This is just a short tutorial. If you don't do anything else, run through this little tutorial on the naive Bayes model. And this is using now, I'm taking a shortcut. I'm not building this from scratch. I'm using sklearn, which obviously makes all of this super, super easy, which is fine. If you really want to dig into it and understand how to write this code yourself, there's plenty of examples for that. And so this mimics what we've done in chapter 6 with a smaller data set, and talks about how to evaluate it with the confusion matrix. And there's a link there for understanding confusion matrices. So I think that's pretty cool. Hopefully that'll be a good resource for you. And I'll have this built out. And again, the idea behind this GitHub repo is, as we're getting into our modeling for our project, this GitHub repo, which will do Bayes classifiers, logistic regression, we'll add in time windowed aggregate features, and then we'll be using TensorFlow, neural nets. So we'll have examples here that will kind of help you explain the algorithms and the modeling behind the work that we're doing. So I hope you'll enjoy this repo. You can fork this, do whatever you want with it. Okay, let me go here and if you have a question, unmute and ask. I think that would be better. Does anyone have a question? I'll wait just a minute. Sounds like a party in the background. I have this vision of the whole class in one big room, just having snacks and breakfast and whatever, and having a good time. So I hope that vision is accurate. I hope that would be nice. Any questions? Harshini, anyone responding on Piazza or the message board?
No, there's no questions on Piazza actually.
Okay. All right. And everyone, please use Piazza also. And Harshini is going to be monitoring that. And you can always get in touch with her or me if you want a one-on-one session. I can set it up in a minute. I'm not doing much here, so except for working. So I'm happy to be available to you and help. This is the great online experiment. All right, let's move on. Close that tab. And let's see what we've got here. Next, what we've gone through our chapter 6 summary. I've gone through the GitHub repo. I hope that'll be useful. Any suggestions for that, or if you need to see some other resources or even want to have a lecture specifically on one of these models or algorithms, let me know and we can set that up. And then we've got our introduction to chapter 7. And chapter 7 goes into logistic regression on Spark on our session on Thursday, which is my idea was lecture on Tuesday. And then if there are particular questions that need extra review, add that to a lecture on Thursday, or just have open office hours for the project or cloud engineer track or anything. So we'll be back online on Thursday and on demand, of course. So let's go ahead and take a look at chapter 7. And I've got that down here. Here's an intro to chapter 7. Chapter 7, I think, is one of the chapters that probably reviews content that we had in our knowledge discovery and databases class. If you had me for the class, I know different professors do different things in that class, but in that class, I use it as an overview for the whole machine learning process, not on cloud, on doing it locally, and where we also cover, we went into detail on several different techniques, including linear and logistic regression. And if you remember, we did classification using decision trees, and we did association rules. I think those are the main ones. We did not go to neural nets, and we're going to be getting into TensorFlow and neural nets here. So chapter 7, we've already moved from one variable analysis. We started with departure delay. Remember, this is a case study, and it's always important to keep that in mind, because I think that's a real benefit of this class, to actually have, instead of like doing one-off looks, we've got a case study. That's the whole knowledge-based system. We've got a case study that we're following and we're building in the cloud. So exciting. And we're seeing how this develops. And it's fairly easy case study. It would have been easier if we could have done the iris data set, which would be too small, but something different. But this is kind of an interesting case study because it does have a time feature. It's got some different features. So I think it's pretty interesting. So we've moved from one variable analysis from chapter 6, departure delay, or previous chapters, departure delay. Chapter 6 brought in departure delay and distance. And we saw that with the greater distance, that time, that is that threshold of when we cancel, moves up, because we have a chance to make up the time in the air. And boy, if you've flown a lot, which I know all of you have, that is certainly true. I'm always amazed at how much can be made up in the air when we've had late departures. And of course, the airlines use some buffers also with these. And I've been having some fun watching the prices of flights, and they seem to have really gone down. I could fly out to Boston for right around $100 for a round trip. I don't know if you've been watching the flights. Of course, you're taking a big risk flying anywhere. Boston's not a good place to go with the coronavirus. Yeah, but anyway, flights seem to have gone down quite a bit. So we're going to add in more variables, and the variable we're going to look at now is taxi out. Let's take a look at taxi out. So what taxi out is, I'm sure everyone has been in this situation. If you have too many planes stuck on a runway, then your flight is likely to be delayed. So does the taxi out time tend to, so we've looked at departure, we've looked at flight distance. How about taxi out? How does that affect the delay? And it seems like, of course, that would affect the delay. And so when I flew out from Minnesota last year for SIGSI, which was canceled this year, after people got to the conference, it was canceled right before the conference started. That was crazy. But we had a long line of planes flying out from Minneapolis, Minnesota last year, right about this time of year. Why? Because there were about 2 feet of snow on the ground. All the planes had to be, it was extremely scary. I'll share the video of the icing with you. So be careful. Here's what you need to understand when you're starting to add more variables into your decision. I'm going to go ahead and, is there a question? Whoops. I'm going to mute everybody just because if you have a question, though, unmute and ask, and I'll stop and I'll pause right now and see if there is a question. Feel free to ask questions, and Arshini's monitoring Piazza and the messages also. So careful, do we need all 3 variables? So you don't just add all the variables in, although this chapter, since we've got these amazing cloud resources, it does show throw all the variables in. Remember, we've already restricted them to a certain subset. Throw all the variables in, use the power of Hadoop and our clustering to go ahead and then remove variables one at a time to see how we are improving. But of course, there's lots of other ways we can do feature engineering and see which features are the most important. And that's what I'm going to have for you in the GitHub site. So Occam's razor, is preferable to use a simpler model to a more complex model. If you've got similar accuracy, always choose the model with the fewer variables. That is better. Extra variables also mean more consideration with respect to our machine learning checklist. So that checklist, if you remember, as we have extra variables when you're ingesting new data into your model, whether that's done on a nightly basis through some sort of a cron job or however we're ingesting new data, are those variables, do they need pre-processing? And is that expensive in terms of time? Is the pre-processing extensive? Is retraining the model going to be expensive because of these new variables? So it's not just does the new variable improve our decision making, which is important, but it's also what's the cost of adding that new variable as well. So that's that whole knowledge-based system and what you have to consider. You'll have to look at new variables, how they're prepared. Is the data consistent? So as you bring in new data, does it stay consistent? You know, the site where you're getting the new data, if that's the case, is that going to be something that is reliable as well? Are we even including the right variable? So, you know, feature selection is important, and we don't do a lot of work on feature selection. This is the chapter. This is a great time to review what you know about feature selection. So here's some other features we're looking at also. We've got this taxi out time we're going to consider. What about a timestamp? So a timestamp is too unique, you know, for any of these things. We don't want just a timestamp because, you know, down to the second or millisecond it's unique. It doesn't group the data in any way. It's too unique. And with all the records that we have, it'd be a nightmare to add this in. But how about hour of day? Maybe we could take that timestamp, and that's what the chapter does, and pull out the hour of day. Is that meaningful possibly to our decision? And so if you think about the hour of day, if you're thinking about booking flights, I know you give some consideration to, you know, do I want to fly out extra early? Do I want to fly out later? We know that the later we fly out, that the lateness of flights coming in and getting that plane ready to go again, the hour of the day can compound lateness with our particular plane. So hour of the day can be important. And also the busyness with taxi out times and everything, isn't it busier at certain times other than others? So I know we all think about the things that you consider when you're flying, and those might be important variables to add into your model. And then another one that's really cool that this chapter goes over, the airport, right? Well, there's a lot of airports. And so we think, well, we can't just use the airport, but how about if we use that in our logistic regression model? We're going to have to use one hot encoding. We covered that in KDD class. If you haven't had that, get with your group. And again, there will be an exercise on my GitHub site that shows what all of this is. With a separate data set, I think it's good to look at a different example, and we'll be looking at more localized examples. We won't be actually using cloud data, but just something simple so you can see how these things work. So basically, one hot encoding, does anyone know what that does? I'm going to throw out a question and see if someone would like to unmute their microphone and say what one hot encoding does for categorical values. Let's say if we've got a categorical variable that shows north, south, east, west, northwest, northeast, what would one hot encoding do to that variable? Does anyone know the answer? I think you can unmute yourself. Harshini, is anyone responding in the messages? You might respond in the messages.
No one responding in messages.
No one knows what one hot encoding is. That's definitely going to be an exam question.
You can even type your answer in chat.
Yeah, put your answer in chat if anyone knows. And there's this little tool, I don't know if anyone knows about it, it's called Google. And so if you want to put it in chat, what you can do is look it up in Google, copy and paste, and we won't fault you for that. Yeah, we'll send it in your own words. But so one hot encoding will take a variable, one feature, like north, south, east, west. So we'll do airport code, and then it takes that. So if the airport code, the code for the Charlotte airport is what, CLT, right? Charlotte. And so what it will do is it will take that airport code, and if there are 5 airports, it'll put a feature in for each of the 5 airports and put a 1 or a 0 whether that airport is present. And so it exponentially adds to our features because it flattens that feature out. And generally, if there are, like if you have north, south, east, and west, it can add 3. It might add north, south, east. And so if it's north, it'll be a 1, and the other 2 will be zeros. If it's south in that one feature, and it'll add 3 features for that. If it's south, it'll put in a 1, and the rest will be 0. If it's east, it'll put in a 1, and the rest will be 0. If it's west, you can take all 3 of those, it'll put all 3 of those features and put them all at zeros, and that's west. Or sometimes you can add the west category. So that's what one hot encoding does. the chapter goes over this. So airport is definitely important, but it's categorical. It may need transformation with one hot encoding. We're gonna have to think about that because that is computationally expensive because we have so many airports. Basically, I've also got a link here. I'll be building up. I didn't have time to build up the GitHub site, and I'll have that ready on Thursday since this week is Chapter 7 week. But there is Scikit-Learn has some great modules on feature selection. Obviously, that's the easy way out. If you really want to understand it, you'll learn how to write the code for some of these things, and there's lots of examples out there. But for our purposes, we'll use Scikit-Learn. We'll learn so many other things. And in Chapter 7, also, it talks about these 3 data sets that we'll be using. We have a train, a holdout data set, and then a test data set. And I know that there are always a lot of questions on why 3 data sets. So Chapter 7 really gives you a good introduction to that. We've looked at scaling is important for your numerical variables. You're going to want to put those in the same scale. Clipping is kind of interesting. You may not have been exposed to clipping before, but that's where if we have extreme values, like for the flight distance, maybe flights over 2,000 miles, really they're all the same. And so we'll clip, and if we've got flights that are 2,000, maybe 2,200 miles, 2,300 miles, we'll clip that and they'll all just be changed to 2,000 miles. For our decision. So clipping is something that's considered, and the chapter talks about that. That's where extreme values are set to a boundary. And then also we're going to set the data set into 3 parts. So the training, we all know about the training data set. That's where we tune the weights of the model. Logistic regression does weighted probabilities. So we'll use the training data set to get that tuned. The holdout data set is used to evaluate the impact of model changes. That's what we're going to use like for different feature selection use adding features and subtracting features. We'll evaluate the impact of that. And then the test set is totally independent. That's where we use to gauge the performance of the final selected model that we use based on the training and the holdout set. So those things, that's when you have 3. Many times we're just used to using training and test, but you can use a training, holdout, and test, which is what our sample in the chapter does. It's a great chapter. Highly recommend reading this chapter. This one's pretty important, even more so than Chapter 6, I think, because of the feature selection. Great material in the chapter. And so then we go to logistic regression, and that's the modeling technique. We use Bayes for classification in the first one. Now we're going to logistic regression. It's important to understand that. I've got many links for logistic regression. I think that's a basic, linear and logistic regression, just, along with classification, just basics that we understand. We've been exposed to in statistics quite a bit. And again, I've got reviews for you on that. So basically the training data in a logistic regression model learns the set of weights for the features. We'll evaluate it and tune it. Whenever we want to make a prediction for a new flight, new data coming in, we recreate the model from the saved data. We pass in the new data. For logistic regression, we compute the logistic function, and then we obtain the prediction or the serving part of the model. And our training happens less frequency. Our prediction can happen in real time, and then we'll choose, when to retrain the model, because we'll basically be doing this as, as we're flying. We're going to want to have an app that's developed from our model, or, some sort of a way to go ahead and put the parameters in, and then see if we should cancel our flight or not. So our model goal, again, just to review, we're interested in estimating the likelihood of an arrival delay of more than 15 minutes because we've got a very important, expensive meeting and we don't want to be late. We want to cancel the meeting for which we cannot arrive 15 minutes early. If the likelihood of arriving 15 minutes early is 70% or less, we want to cancel. So this translates to us looking for arrival delays of more than 15 minutes. If that's 0.3 or more, we cancel the meeting. All right, and so this is a great, we're almost out of time. This is a great a little video. It's on StatQuest. The beginning of this will make you smile. They've got a goofy little song that they sing every time at the beginning of the video. I like this. It explains it. Definitely highly recommend. If you could not tell an interviewer how logistic regression works, how that model works, then you need to watch this, right? And the same with linear regression. But so watch this, and this will give you the basic knowledge behind the model. Okay, we've got that done. Let's go back here. That's chapter 7. I've got a bunch of optional resources to chapter 7. There's some logistic regression with Python. These GCP instructions. I don't know that I'd recommend putting it in GCP. You can try that. You can read through the instructions, but I do have all the instructions for getting this up and working in your own Google Cloud environment. And there's a shortcut to PySpark. The chapter 7 tutorial does get you into PySpark, and here's a shortcut for getting into PySpark that makes it a little easier to get in. And maybe I'll have a demo. I'll try to put a demo video up for my work in GCP. And then this one was kind of interesting. So Google had a presentation on Spark ML, BigQuery, and Cloud Data Lab, and this kind of mirrors what we're doing in chapter 7. So if you want to take a look at that, you'll see one of the Google workers, and he looks like someone from California presenting, which is fine. I'm not saying it, but so you'll see one of these Google workers presenting and giving an example of that. So you'll get, I think that's kind of entertaining too, but it's a nice little watch for 40 minutes. All right, so that's my introduction to chapter 7. What I'd like for you to do is communicate with Harshini or with me and Piazza or in the chat feature, and let me know if you have questions about this. But if you have questions about logistic regression, take the time. You should be spending 3 hours outside of our sessions like this working on the class just to get the content. And as you know, we've got a quick lab that was due. I looked, and I think everybody's done the quick lab. So you've got the quick lab going. There's not one for chapter 7. For chapter 7, I've got this data camp assignment, and I've moved up the due date. I thought the due dates were kind of crazy, having you have everything due by the beginning of class Thursday. And so why not? So for this week, we're covering chapter 6 and 7. And so the due date will be beginning of class on Tuesday. And let me know if you have any questions with that. So we're continuing, and data camp should be set up, ready to go. As I went into it, I didn't see that I had the assignment set up. I don't know how I missed that, but anyway, click on that link and you can get into data camp, and that's due by the beginning of class on this Tuesday. So we've got some time. I'll have some questions answered about that. And then your projects are due by the end of day Thursday, 3/29, and so that next deliverable, we've gone over that in class. You can go up to the top, and we'll go over that on Thursday. And if you want a table of contents on your README, I can even show you how to do that in GitHub. And if you want to spin up some code in Google Colab, I could show you that GitHub site that I have has a good example of all of that, and I'll be glad to share that with you. It's pretty easy to set up. All right, I'm going to unmute everybody. All right, you're being unmuted. Stop the party. We had 17 join in, and let's see, I'm going to unmute.
We have large hands.
Everybody, any questions?
She was doing, yeah.
We're finished today, so if you have any questions, if you could mute your microphone, or actually, I'm going to mute you again.
No questions.
Okay, I'm going to mute you and you can unmute if you have a question. That would probably be better because I'll start getting the feedback. I'll tell you what, we've only got 17 participants. If you want to unmute and just say hello to the group, oh, here, I'll unmute one by one. I've got Akshaya. Let's see how this works. I don't know if I'm able to unmute you. It's not letting me unmute participants. Let's see if that one. I don't
Hello,
think
Professor.
Did it unmute?
Yeah, you did.
Okay. Any questions?
Nope. I'm
Okay.
good.
Okay, good.
Thank you.
All right, you can go ahead and mute again. Yeah, like I said, I'm getting used to this. Let's see. Aditya, are you there?
Yeah, hi.
Hi, how are you?
Yeah,
Any
I'm doing good.
questions?
Yeah. No questions at all.
All right, great. Well, we're just all Okay, I should put on my glasses here. Who did I just unmute? Anarita?
Yeah, Professor. I don't have any questions.
Okay, good.
Yeah.
All right, that's great. Did I already unmuted Aditya, I think, didn't I? Aditya, did I already talk to you? Nikata? Nikata? All right. Well, I can see. I'll tell you what, just unmute if you have a question. We could go down. I can see who's here. Welcome, everyone. Thank you so much for joining in. I'll push the recording out. I sure wouldn't want to watch this recording afterwards. It's a lot more fun to join in live, I think. And I really, really appreciate you joining in. Any suggestions that you have for making this online session better, let me know. Please, you can let Harshini know, or you can let me know. Hopefully you feel like this went pretty well. I am available. We can set up a Zoom meeting or a WebEx. I kind of like Zoom better than WebEx. This seemed to be pretty simple. And again, those of you that joined late, we've had a lot of problems with WebEx. We've got so many people using it at certain class periods, and our WebEx account has been having a lot of delays. We had a class yesterday with over 120 participants, and they experienced some problems from what I understand. And our faculty discussion board has been filled with delays. Don't use WebEx, use Zoom. So I don't know if they'll work that out or not. But this worked pretty well. We didn't have our whole class in, but we had a lot. So if there aren't any other questions, if you want to take the time to unmute right now, if there are questions. Otherwise, I will see you again on Thursday. I'm going to stop the meeting, see what I need to do with the recording, and see if I can post that on the our Canvas site, and then I'm just available. All right, so we'll meet again Thursday. You've got some homework, please. The Google form, if you're interested in the completing the certificate, and then later you can sit for the certification exam. But completing that certificate, I need to know who's wanting to do that by Thursday, because I will get our cohort started, and we'll have a jam session, Google's term. We'll have a jam session to get started. That will be a separate meeting. That will be probably about 45 minutes just to get everybody on track. And then I'll be monitoring everyone's project progress, including my own. The idea will be we'll keep each other motivated to get through that course, and it will be on an accelerated schedule since we don't have anything else to do anyway. All right, thanks everyone for joining, and I'm going to sign off here.